part of the process flow analysis is not only drawing the processes, designing the process, but we also want to measure the performance of the processes. This gives us insights about potential for improvements, and you already know a little bit about performance measurement on the societal level, on the strategic level, and on the operational level. And this performance metrics for the processes are on the operational level. What metrics are there and what is a metrics? So a performance metric is a measure that measures different process characteristics so that we get some insights into how a process is performing and maybe how this performance is changing over time. And changes over time might either indicate the process improves over time or there's a problem and we need to redesign the process. The most basic measure for the performance of a process is the throughput time. This is the time it takes from the start of the process with the input until the process ends and we have our output. And this includes typically time of the activities that are performed on this item, but it also includes the waiting time. And we do not measure this only for one time we go through the process, but we go through the process several times, and therefore we usually consider the average amount, the average throughput time to characterize a process. Another figure, another metric that we are using is the process velocity. This is the throughput time over the value added time. Though now the throughput time, we just explained it, but what is the value added time? The value added time is when the time it takes that an activity is actually performed. So for example, if you are going through the course registration process, maybe you write an email, send it to RSA, and then they work on it, they make a decision, and at the end you're registered. This would be the throughput time. Now the value added time is only the time you spend on writing this email, and it is the time that the RSA person is checking your registration. The waiting time in between is not considered value added time. Of course, where you need to be careful when you use a figure like this in your own company, if you write an unclear email and they have to ask you 2, 3, 4 questions for clarification, then something is happening, but it's also a kind of wasted time, which becomes not really visible in this process velocity figure. Okay, we have a productivity figure. Like in all economic backgrounds, this is just the output that we create with a given input, whatever this means. This can be staff, machine time, overall time, money, etc. We have the utilization of a process, the utilization of an equipment that we use within the process, the utilization of labor that we use in the process. And the utilization is defined as the time we really make use of this resource divided by the time the resource is available. So if we have a machine to produce something and we need 20 minutes of this machine to manufacture something, but the machine is available for 120 minutes, then the utilization would be 20 over 120, 1/6, so a very low utilization. when you discuss these measures, let's say by default many people prefer a high utilization, but you need to be careful because a high utilization can have several drawbacks. Typically you need to wait much longer until something is happening. You need to wait for this resource much longer. So if you have a low utilization, this is often much better for the throughput time. So you need to take into account the price of this resource and the economic impact. For example, if you consider a checkout counter in a grocery store and it has a high utilization, so that means several cashiers are working and many customers are waiting on the service from the cashier, then this cashier has a very high utilization. However, the drawback is that the customers have to wait a long time. So a high utilization is not always automatically a good signal for a process. And the last and final metric that we consider is the efficiency, and in particular here we define the efficiency as a comparison between the actual output of a process compared to an expected standard output. This is the definition of efficiency here. In other contexts you will find slightly different definitions and understandings of efficiency. But here we compare it with a standard output. Of course the question is, where do we get this number? What is a reasonable expectation of the standard output? Let's look at these metrics in an example. We have one company called France Title Company. They are processing titles. So what is a title? In real estate, when you want to buy a house, the house might be used as a mortgage for a bank, and the bank has certain rights on this house. And to make sure that when you buy a house, that not other persons have all the rights on this house, that might create a lot of trouble for you, you do a title search. You try to find out all the legal requirements, if the house is somehow clean in a legal terms, if it's not used as a mortgage with other financial institutions, so that you don't have any troubles after buying the house. And this company is performing such a service. So France Title Company is analyzing its operation in an effort to improve performance. The following data have been collected. It takes an average of 4 hours to process and close a title, with value added time estimated at 30 minutes per title. Each title officer, this is an admin guy who's working on this task, is on payroll for 8 hours per day, so working 6 hours per day on average, accounting for lunches and breaks, etc. Industry standard for labor utilization is 80%. The company closes on 8 titles per day with an industry standard of 10 titles per day for a comparability facility. Okay, we have a lot of data here. We have all data related to our process performances. And now the question is, and the task is, determine process velocity, labor utilization and efficiency for this company. What conclusions can you draw? Okay, let's start with process velocity. This was, for the process velocity, we need the throughput time and the value added time. Now, the first thing that we need to be careful about is some of the data is given in hours. Here we are given data in minutes, and this is some daily data. So we need to make sure when we calculate these performance metrics that we are always using consistent units when calculating the performance measures. Yeah? For example, everything on an hourly basis or everything on a daily basis. And the process velocity is throughput time over the value added time. Here we have the throughput time. It takes on average 4 hours to process and close a title. And the value added time is 30 minutes, so 0.5 hours. 4 over 0.5. And this is 8. Yeah? So we have a lot of free time, a lot of idle time, a lot of time where we spend waiting in this process. If the value added time would increase, then the process velocity would go down. So if we have a process velocity of 1, then the throughput time is exclusively used for value added time. And we will not have a process velocity of smaller than 1. That's not possible because the value added time will always be smaller than the throughput time. Okay, the next one is the labor utilization that we want to calculate. The time a resource is used and the time a resource is available. So labor is related to the title officers. Title officer is available for 8 hours a day, and they are actually able to work for 6 hours a day because there are some other things, not only breaks, but maybe some meetings that are not related to the actual work performed for coordinating efforts. So the labor utilization is 75%. And you see the 75% in perspective with the industry standard, which is 80%, is slightly lower than the industry standard. So that means there are other companies out there that use the labor more effectively, more efficiently. And finally, we look at the efficiency, which is the actual output over the standard output. The actual output is 8 titles per day, and the industry standard is 10 titles per day. And our efficiency is 80%, so we are working quite significantly below the industry standard. Now this gives us a good starting point to look into the reasons for these things. Maybe our staff is not as well trained as in other companies. Maybe we are not using technology to coordinate our activities and to automate our activities. So now we don't know the exact reasons why our efficiency is much lower than the industry standard, but by using these performance metrics, now we have a starting point to dig into the details and try to explain why we are less efficient. And this is the use of the performance metrics.